All right. Well, thanks everybody for joining. My name is Eric Cochran, and I'm the IOP chairperson this year. And I'd like to welcome you all to the IOP Midweek Mixer. We'd love to see and hear from you all. So please make sure your video and audio are properly enabled. Please keep your video mute unless you're asking a question, just to minimize echo and background noise. And then our format here is we're going to have several speakers today. And so at the end of their 5-minute remarks, there's going to be an opportunity for questions. So we'd love to hear from you about those questions. So in order to ask a question, you can either use the raise hand feature in the Zoom interface, or you can also type them directly into the chat box, and we'll make sure that those get addressed as time allows. I already introduced myself, so would the other members of the IOP organizing committee like to say a few words?
So I'm Helen No, and I'm from the USDA Eastern Lab, and I'm a Secretary Treasurer of IOP. Nice to see you all.
And this is BK Sharma, again, a research chemist at USDA ERRC Lab, and I'm the Vice Chair for IOP.
Great, and I guess I should mention that my day job is I'm a professor at Iowa State University in chemical and biological engineering, and I also co-direct the NSF Center for Bioplastics and Biocomposites. So before we get into our talks, I'd like to first recognize the IOP award winners for this year. So for the IOP Division Student Excellence Award, we have Tsutomu Chida from Tohoku University in Japan. And the IOP Division Junior Researcher Travel Grant, we had 2 awardees this year. One was a deferred award that was actually conferred a couple of years ago, and then the pandemic reduced our needs for travel funds, and so that wasn't collected at that time. And so that was Adib Hayyan from the University of Malaya in Malaysia. And this year's awardee was Daniel Dedu from the University of Pablo de Olavide in Spain. So congratulations, everyone, for being selected for these awards. So moving on into the just a few announcements. But before we start, we'd like to encourage you all to attend the annual meeting. So that's going to be a hybrid meeting, and we strongly encourage you to attend in person if you're able to, and that's going to be in Atlanta, Georgia, here right at the beginning of May. There's a lot of opportunities to be involved in the IOP that you can take advantage of there in terms of volunteering and networking and career development. As you're registering for the conference, please consider attending our luncheon, which is going to be on the Tuesday of the meeting. So our format for the career development talks today is we've picked out a couple of speakers from various different walks of life career-wise. So we have a couple of speakers representing careers in industry, a couple representing careers in academia, a couple from government research labs, and also one speaker that's right in the midst of getting a new startup company launched. So without further ado, let's start with the speaker. So first, I'd like to introduce to you Tim Abram. So Tim is originally from Sri Lanka, and he received a bachelor's degree in chemistry from the University of Colombo. Subsequently, he came to the United States and got his PhD in organic chemistry from the University of Minnesota. So after that, he completed some postdoctoral work in the Department of Medicinal Chemistry at the University of Minnesota, and he joined the biotech company Ambien in Texas. He returned to Minnesota in 2000 to join Cargill's Process Solutions Technology Development Center as a senior scientist and was promoted to principal scientist in 2004. He was the new product development manager for several years in Cargill's bio-based polyols business unit before he joined the engineering and data science group. In 2014, he was awarded Cargill's Bassey Award for Outstanding Technical Leadership and was promoted to senior principal scientist in 2015 and named a corporate fellow in 2019. Tim is an inventor on over 70 patent applications and has more than 35 granted US patents. And so with that, Tim, we'd love to hear from you about your career.
Thank you, Eric, and for that introduction. And I think you gave kind of instructions on how to, present a career. So I'll talk about a little bit about the career. As I mentioned, I got my BS in chemistry, but I've always been interested in the biological sciences. And so when I got my PhD, I got the natural products chemistry with emphasis on organic synthesis and studied the biosynthesis of in specific plants like the cocaine plant. My postdoc in medicinal chemistry was on catalytic antibodies, and that once again was related to my interest in biological sciences, mainly around catalytic antibodies for delivering anti-cancer and antiviral drugs. And that was my first step into getting a job in industry. So as mentioned, I worked for Abram, known as the RNA company. But I decided to return to Minnesota, and in 2000, I joined Cargill, and have been very happy with my position here because I've been here 21 years. Regarding how to get started, I know Eric wanted me to talk about that. So, I mean, obviously, companies hire you for your knowledge, and your ability to communicate that knowledge is critical in finding that first job. And of course, having a high degree, the expectations are that you are innovative, and that's something that was taught early on to me. And then also a learner. I think very often we hear at Cargill is not just a technical depth that you're expected of you, but also technical breadth. So understanding fields that are adjacent to your field, like in my case, it was chemistry, but also to solve problems. So are you a problem solver beyond just being able to be innovative? Uh, in terms of achievements, Eric, I think you had another slide. I think I put that up. I don't know, Eric, you had, yeah, that's the one. So in terms of the achievements, certainly Zoran is on the call. Our partnership with Pittsburgh State University to develop the soy-based polyols was a highlight of my career. Essentially in 2006, the project, since once we commercialized, we won the Cargill Chemists Award, as well as the Presidential Greek Chemistry Award given by the EPA in 2007. I was also instrumental in working on the metathesis of vegetable oils using metathesis chemistry. Many of you have heard about that, about metathesis of oils to develop various compounds like carboxylic acids, hydrocarbons, waxes, and such as those. The project, while it once we completed that work, it was spun off as Elevance. Some of you have heard of Elevance, a company that that went on to commercialize some of these technologies. One thing I've also wanted to mention, I talked about technical breadth. So it was beyond just oils-based chemistry. I've been involved in making organic acids that then are converted to like acrylic acid to make super absorbent polymers like polyacrylic acid. I've also been involved in high intensity sweetener projects involving fermentation-based monotin, as well as some of you who may be using Truvia that's on the market is a Cargill product that I was involved in very early on in the extraction and isolation of the stevia glycosides. What has been rewarding to me is the fact that I've been able to use my organic chemistry knowledge across multiple business units, and that's what I've been really grateful for at Cargill, being able to work on various projects. So my work has not been limited to industrial products and oils. Excuse me, I've worked on starches, I've worked on food products, both oils, starches, sweeteners, as well as animal feed, such things as proteins and micronutrients. Another key aspect of my work has been solving critical technical problems. So it's not just producing new products, but also solving critical problems that the company faces in production, for example. So someone might have a question about, okay, what is this new smell that we are getting from this product that we produce and the customer is rejecting? So trying to figure out the root cause of what the issue is, and then using my organic chemistry skills trying to solve that problem. In terms of challenges working in industry, certainly project timelines are really critical, even though in graduate school, you keep hammering away at a project to solve the problems, but it's always project timelines when you work in industry. And then always the commercial guys looking at cost versus benefit. How much are you spending? Is it really going to bring value at the end? And business cases can change. For example, you might start a project that you expect to produce a product in 3 or 4 years, but suddenly halfway through the business cases change and you got to switch gears or even kill the project. So those are some of the challenges that I've faced working in industry. So that's kind of a summary of what was requested of me, Eric.
Yeah, that's perfect. And you're like exactly at 5 minutes. So beat that, everybody else. Do we have any questions for Tim? I learned a lot about you today, Tim. Thank you.
Good, thanks.
Well, Tim, Eric, I have a question for Tim. So
Okay.
you mentioned that, okay, thanks. The challenges that you faced with cargo, is it similar challenges that you faced from you working at Ambient to going to cargo?
So yeah, Ambient was a smaller company. It was a startup. So but it still was, you got to make money, right? So ultimately companies exist to make money. So you're always conscious of cost, but the research aspect was a little different there than compared to Cargill. But yeah, you still feel the same pressures. Project timelines was a little more flexible actually because it's a little more a startup company compared to the Cargill, where you have management saying, okay, you got so much time to complete this, and then we got to reevaluate every couple of months. So there's always the business case, cost versus benefit evaluation constantly throughout a project. Every 3 to 6 months, they kind of keep refining the numbers, but not at Ambient. We didn't face that. It was producing new products, which was quite interesting, but we had a little more flexibility there.
Thank you.
Sure.
Anybody else?
I think I have a question for Tim. Yeah, so I'm Dajun Yu from Virginia Tech. I'm currently in my 4th year PhD and plan to graduate this summer. And I'm right now looking for a food scientist job in food industry. So I'm wondering, do you have any early career advice, tips, or suggestions for young people who will step from graduate school into the food industry world? Or not anything you think is important to notice in the early career, but nobody tells you at that time? Thank you. It's a very general question.
So, I mean, yes, it's very much of a general question, but certainly remembering, and I think getting started, as I showed in that second section on getting started, being able to communicate your knowledge very effectively. And whenever you present yourself at an interview, showing that you have the ability to be innovative. So it's in addition to what you accomplished in graduate school, being able to convince them that you can come in and serve the purposes of the company. So they're not only hiring you for your knowledge, what you have, but also what you can do for the company, right? So that's what they see whether you're a good match or not, right? And also, being able to talk about, project timelines. At the bottom, I talk about the challenges of running a business. So you also have to convince them that these are things that you think about. It's not graduate school where you're trying to, solve a problem, find something new, but how does that apply to a company that wants to make money, right?
Yeah, okay. Yeah, thank you.
Hopefully that was helpful.
Yeah, it's helpful. Thank you.
Okay, and we have time for one last question I just saw come in through the chat box. So the question is, Tim, what would you say the most important quality of a researcher or inventor would be to create a new product or a patent?
So certainly understanding what the landscape is really critical, and being able to critically evaluate, I think, what others have done, is something that not a lot of people do very effectively. So you find what the white spaces that you can operate in, but also it always comes back to what business need, right? Because the reality you get to work on a project that's kind of outside the business need. So that to me, that those are critical things in working industry. Hopefully that answered the question.
Yeah, very nice. Well, thanks again so much, Tim, for participating today.
Sure.
And so now we're going to move on to Tim Umasaw, who has over 35 years of experience in the life sciences, including 18 years at Monsanto. He earned a master's degree in physical chemistry and a PhD in molecular biology, and also earned an MBA from Washington University in St. Louis. At Monsanto, he led multiple cross-functional teams focused on product development using conventional breeding and biotechnology, including high essential amino acids and high oleic soybeans. He has been a member of the AOCS since 2004. He joined Arvgenix, which later changed its name to CoverCress in 2016, and is currently leading its technology and business development efforts. CoverCress Incorporated is a St. Louis-based startup focusing on development of a pioneering solution to sustainable agriculture by converting pennycress, a cover crop, into a profitable rotational oilseed winter crop. CoverCress has won numerous grants and awards and was featured in multiple publications, including Forbes magazine, as one of the 25 most innovative ag tech startups. So with that, Tim, would you like to tell us about your career trajectory over the years?
Sure. Thank you, Eric, for the introduction. I actually probably misunderstood the importance of this background slide, and maybe if you can give me ability to share. I wrote similar stuff that Tim Abraham, but I'd like to share my screen. Can I do that?
Yeah, Bill, could you manage that?
Yeah, let me see if I can just change it so that he can share a screen.
Yeah, while Bill is trying to do that, I'll start. Basically, my career started just like Tim's, outside of biology. I started in physics, got my bachelor in science in physics, was very strong in physics always, but then kind of gradually migrated to physical chemistry and then biology. And for example, my PhD was already in genetics and biochemistry. And when I arrived to the United States in 1991, I actually was already a sort of young molecular geneticist. And but that experience, physics and chemistry, is really helping me throughout my career. And basically from there on in '98, after a stint at the University of Missouri, where I was studying different aspects of gene expression, I moved on to Monsanto, where I spent 18 years working on various quality traits. For example, improving soybean protein, improving soybean oil, and also working on herbicide tolerance traits in different crops. So that has really prepared me well for my current role at a startup. And I would say today we are a mid-stage startup where we're developing, domesticating a common weed into another profitable crop. And this slide that you're currently seeing is actually showing you the pennycress and covercress and the transition, and also showing the step change of the growth of the company. So it's very nice to be in this position, and in large part we can attribute our success to Janet Cheney's brother, who was one of the co-founders of Arvgenix, and his leadership. He led the company for several years before he kind of stepped down into the executive chairmanship role. So bottom line, can I share my screen now or not?
Yeah, you should be able to. I made you a co-host, so you should be able to share your screen
okay.
now.
Okay, let's see. Yeah, can you see my word?
Yep.
Yep.
Yeah. So we just covered kind of the item number one. And with regard to what is key to getting started in the field, my answer to that is try to pick the area that is poised for growth. And I, in my heart, believe totally it's bioeconomy. If you are somehow related to chemistry or biology, and if you're in the computers, it's artificial intelligence. That's the advice I'm giving young people all the time. And in the bioeconomy, specifically, I have a passion for sustainability. I think biofuels and biomaterials just have, fantastic future. And with regard to my most rewarding moments or the achievements, I would say when I was at the University of Missouri, made important discoveries in oxygen-signal transduction that I am now in the textbooks. At Monsanto, it was my work on High Lake soybean. And currently at CoverCress, it's a domestication of a weed in a record time into rotational winter crop, which is CoverCress. I'm very proud of where we are today. And with regard to what's how the startup environments is different from large companies like Team Abraham is working at, I would say most rewarding in startups, it's ability to move fast because there is no red tape. We have ability to really make a difference to the world, ability to wear multiple hats. It's a must-have at the startup and learn a variety of new skills. At a large company, you have less of that. If you startup successful, you have faster career growth than at a large company. And obviously, if it's successful, one of the most important aspects is financial opportunity. The challenge, on the other hand, when I started, I found myself, relative to Monsanto, having much less resources and a safety cushion. If we make one wrong move, we could put our investors and ourselves in a really dire position. And for people like myself, it was not as important because I had a full career at Monsanto. But for younger people, it's a partial kind of or serious lack of job security. But nevertheless, I think I'm really enjoying what I'm doing. I highly recommend that kind of experience in addition to any other experience that you may have, either in academia or in a large company. Just believe in yourself. How am I doing on time?
That's about perfect.
All right, I think I'm gonna stop right here, and people can ask me about what might be different for younger people. I think I tried to cover that. I'll stop sharing now here.
Questions for Tim?
Hi, Tim. I have a question.
I have one. How you doing, Tim?
I'm doing good. How are you, Bob? Good seeing you again.
Yeah, it's been a while. So on your work on the pennycress, the lower rusic acid stuff, is that considered a project that's been completed, or you still have some things ongoing with that?
That's a great insightful, very insight kind of question. Yes, from technical standpoint, it's completed. But if the purpose of the oil is to go specifically only into biofuels and specifically renewable diesel, the lower rusic doesn't have a whole lot of value. So right now, I can tell you all varieties do have lower rusic. But going forward, it may change if the future customer, which most likely will be a large fuel producer in this company, in this country, they may want to change that. So I still say that both options are open.
All right, thank you.
Tim, a quick question for you. How working in crop sciences changed during your career?
Yeah, I think when I started came to Monsanto from academia in large part because in '98 it was kind of considered Microsoft of plant biotechnology, leadership position and so on. Still, the dramatic change, first of all, obviously the impact of computers and genomics information and so on. So now I would say it's kind of a must-have if you're a geneticist to have an understanding of both genomics, being able to work with large data information, large data sets and things like that. And going forward, I can tell you, I'm convinced that because CoverCress in the forefront of gene editing is a new way of breeding. So I cannot see, for example, future, crop researcher or breeder without, deep understanding of gene editing, because that's the way, from the early days of selection walking the fields, the new way of selecting for useful traits would be through combination of computer science, bioinformatics, and gene editing.
Thank you, Tim.
Great. Well, thanks again, Tim, for adding to this. That was really interesting. The next speaker is going to be our first academic speaker. So Zoran Petrovic has been at this for a good long time. He's got his bachelor's of engineering in chemical technology, with a specialization in organic in 1964 from the University of Belgrade in Yugoslavia. In 1969, he got his master's degree in chemical technology from the University of Zagreb in Yugoslavia, and then a PhD in material science in 1974 from the University of Strathclyde in Glasgow. His career started in Sarajevo as a research engineer at the R&D Center for Power Electrical Engineering. And in the same time frame, he was also a professor of physical chemistry of macromolecules at the University of Novi Sad in Yugoslavia. He was a visiting professor at UMass in the Department of Polymer Science and Engineering from 1992 to 1994. And after leaving UMass, he moved to his current location, where he's the founder and research director of the KPRC at Pittsburgh State University. So with that, Zoran, we're very eager to hear from you about your long and very productive and successful career. And you're muted, Zoran.
Can you hear me now?
Yes, perfect.
Oh, okay. Probably I'm the oldest one here. And my career was really struggle for survival. As you can see, I was everywhere. And I came to this country in I was in US first time in 94, where I was doing, 84, where I was doing postdoctoral research at University of Massachusetts. And then I established some relationship with them, and I used to come every summer to help Professor McKnight, who, especially in the area of experimental work with students. I was always interested in experimental work. I was teaching physical chemistry, and theory is very nice, but unless you something confirm experimentally, you shouldn't believe it. So anyway, I was, after University of, when actually the war, the trouble started in Yugoslavia in 90s, I came to this country, and I came again to University of Massachusetts, where I stayed for 2 years working on different projects. I was even consulting at that time with Converse, which helped me survive actually, because they are paying me well. And I was developing different material for shoes, basketball shoes. Unfortunately, they went bankrupt and they were bought by Nike, but they continues as a their logo is still with Nike as a Converse is there. Anyway, I had to move to look for a permanent job, so I was offered a job here in Pittsburgh, which is a small university of 7,000 people, and I started from nothing. This was not a really a research institute, research university, but we have very strong plastics engineering program, which was a good thing. And then I started, making a program, and eventually we formed Kansas Polymer Research Center. I brought some people, I got some equipment, and we have a very interesting way of working. We were not paid by the university, and we are at the university, but we were paid by project that we bring here from different. So really all my life here was a struggle for projects, but fortunately I was successful. Anyway, when I was leaving University of Massachusetts, then the Professor Porter, who was advisor at what is the United States Department of Agriculture, okay. He said, you should try to work on agricultural raw materials. And when I came here, my first application was to USB, and fortunately I got the project from them, and this was to me a very great thing, because finally I had an independent project. And we started successfully applying for projects, and essentially we were like prostitutes working for money, and going everywhere where we can get money. We were not paid by university. My salary was paid by a Kansas Technology Enterprise Corporation, which went bankrupt later on. I don't know what happened, but anyway, I continued this. I didn't have a laboratory, so I accepted to teach several courses at the university on polymers to get a lab space. Anyway, we gradually started growing, and we had some dormitory which we converted to lab space. 2 laboratories at the beginning and ended with 17 at the end. Unfortunately, then some guy came and offered us some money for a new building, and I have the best building in Kansas for polymer research. It's a beautiful building, and we are crammed with equipment for polymer research. Of course, since I'm polymer chemist and engineer, my first interest was to use agriculture products, and especially oil, and we started working, and we started publishing. People were, at the beginning, there wasn't much interested in this until the oil crisis. And suddenly, where we were on the side, we became on the top of the field because we were working actively for a while. And then large companies started coming to us, to a small Pittsburgh. Then we had Dow Chemical, we had several of them. And one of those large companies offered us a project with DOE. That was a $2 million project. But they spun this polymer part into a new company. And after 2 years, they were not, this was at the time of big economic crisis. They couldn't continue the project, although we were almost on the verge of commercializing our polyol by hydroformylation. Then I met Cargill, and that was a dream meeting, and we continued with Cargill, and that was the most successful cooperation with industry that I had. Before that, we developed a range of polyols and patented them. With Cargill, we could commercialize this. So really, it was very nice journey. So the beauty of our work is that we have absolute freedom to do what we want, provided somebody pay us. And we were able, usually what we do is we do some research in advance, unpaid, and then we apply, if we have positive results, we apply for a grant and we continue like that. So one time I was the best customer of United Soybean Board. We had a lot of projects with them. We developed a lot of materials. Currently, I work with a startup company which works with algal oil. And we are on the verge of, we patented several technologies there, and it's a very nice work. So the enjoyment of ability to create new things from old materials is always a challenge, but we were successful. We published a lot of paper, and we have a lot of patents. And although I am now 80, I'm still sitting in my office and working here with pleasure. So generally, it was very successful way. I'm now retired, but I do have my office here. I do consult with some companies, and we have students here. And I used to bring students who would work for us. We would pay their tuition at the university, and eventually they would become our members if they were successful. So we had a lot, more than 20 people at one time. Now I'm retired, so my duties are different here. We have a new directions in the institute and new management. So I'm a kind on a sideline making decisions. So, but anyway, I'm still having an independent line of research within mostly urethane areas, because we were specialists in urethanes from the beginning, from my PhD time. But now urethanes based on oils. We do sometimes make other materials. We were working on isosorbide. We were working with other materials which are potentially interesting bio-based materials. So this is briefly what I am doing here. And I would be glad if you have any questions to ask?
Yeah, thank you, Zoran. I think we could probably set aside a whole hour for you because I think you have a lot to share with us. Does anybody have a question for Zoran? I know there are probably very many. I have one, and maybe it's not a quick one, but so you've taken a lot of things towards commercialization, and I think you've gone the startup route and you've gone the big fish route with Cargill. So what are some of the trade-offs there between venturing out on your own versus working with the single large entity like Cargill and trying to bring something new to market?
Well, we went for any money available on the market, from small companies. So there are many projects that we were doing aside from oil. One day, a company which was recycling glass bulbs was making glass fibers, and they came to us to make a new material, glass fiber reinforced cross-linked polyethylene or polypropylene. And we were very successful in this. So this is, and there are many products. Here I'm always, what we publish is only on oil. So mainly this is our area where we have over 150 applications in this area, and we were recognized in the field by number of citation, have over 12,000 citation, H factor close to 60.
Yeah, that's great. All right, I think in the interest of time, we need to move on to the next speaker. Zoran, thank you again so much. And for those in attendance, Zoran will be at the AOCS meeting here in Atlanta. So yet another reason to join and attend the meeting. Our next speaker is also in academia. So Frank Dumenil, and please, I apologize if I just slaughtered the pronunciation of your name.
Perfect.
Great. So Frank got his PhD in 1998 at Lille University and spent 6.5 years in Japan, beginning with a postdoctoral stay of 2 years at NIMC in Tsukuba before a 2-year postdoc at Tokyo University of Agriculture and Technology. And he then returned to France as a full professor at Lille University. In 2010, he was appointed deputy director and then director in 2016 of UCCS, which employs more than 300 people. He coordinated the PCRD7 EuroBioRef program, European multi-level integrated biorefinery design for sustainable biomass processing, which consists of 29 partners in 15 countries and managed over 38 million euros in funding between 2010 and 2014. At the end of 2011, he was awarded the RealCat project, Advanced High Throughput Technologies Platform for Biorefineries Catalysis Design, in the amount of 8.3 million euros. He was further nominated as responsible of the French mirror of the CNRS Solvay Laboratory in Shanghai for Eco-Efficient Products and Processes Laboratory, and responsible of Hub 2, Science for a Changing Planet of the iSite ULNE, a large-scale project for redesigning the local university landscape. He also coordinates the program for early stage researchers in Lille, and also the H2020 doctoral program between 2019 and 2025 for nearly 5 million euros. Beginning in 2022, he's been nominated as the Vice President for Valorization and Link Science Society of the newly merged University of Lille and the worldwide largest French-speaking university with about 78,000 students and 7,200 staff. So another a very accomplished person in his career. And so Frank, we'd like to hear all about it.
Thank you very much, Eric. So when you asked me to participate to this event, I just looked back in the back mirror and I saw what is written on this slide. I will tell you a bit of this story. So after my PhD studies in France, I made a postdoc in Japan. So after 7 years, the French government called me back to France, and what they wanted to for me to do in Lille University is to start the biomass valorization using catalysis, because at that time no university was working on that subject, and the director of the lab asked me to work on glycerol valorization. The point started then. So I started to work on glycerol valorization, developing some oxidation, dehydration. And then the point came that I needed budget, I needed money. And I applied to European project, and maybe by chance, I don't know, something very big came into my hand. I got this 38 million project, which was the real beginning of my career. And then everything from this project changed. Then I obtained the 8.3 million project for a high throughput experimental device, enabling developing more and more chemistry. So I was very pleased to be awarded with the Glycerin Innovation Award by AOCS. I think it was in 2015, if my memory deserves me. And then in my university, Lille University, I was identified as a scientist with a lot of achievements, and they asked me to make a very big project for the university. This is what is called here ICITE ULNE. I will explain a bit what it is, and I think it's my biggest achievement in my career. And I will tell you something that nobody knows for the moment, because this will be announced by the French Prime Minister in two weeks. So please don't tell that. So I designed with 3 of my colleagues a new university, which was launched in 2022. Now I'm vice president for valorization of this university. And we designed 3 hubs. So here is written hub science for a changing planet. And in fact, I was the responsible of this hub dealing with biomass valorization and capitalizing on my achievements on oil chemistry and also on lignocellulosic chemistry. And then this project was awarded to our university. We were created, and if successful, we had some key performance indicators and blah, blah, including science indicators and so on. We will have something very big from the French government. And in 2 weeks, our French Prime Minister will announce that he will give our university 500 million euros to 500 million euros, €500 million to make research. And this is due to this career, in part to the AOCS award I got. It was a huge booster in my career. So thank you so much to AOCS. So this is something I was not expecting, but it happens when you make things, when you make research. So what is key to get started in the field? So I answered, you need money. And this was the same as the previous speaker, Professor Petrovic. So when you don't have money, you need ideas, creativity, but at a certain point of time, you need money and you need to apply for some projects. So this was the key to get started in the field, and I was a bit lucky on that. Then what is the most rewarding in your work? It's when you have a new idea. I will go back to science, and you see your idea is actually working. So I'm very proud about two new ideas I developed. The first one is hybrid catalysis for science. It is mixing in one pot heterogeneous catalysis with biotechs. So we are mixing homogeneous heterogeneous catalyst with enzymes, bacteria, and we are able to make the system working together, like if you would have two nanofactories working together. And why I am very proud of this, because the first time I presented this concept, it was in 2008 in a Congress. People told me this is impossible, you will never succeed. So I decided to make it, and I'm very proud because I proved it was actually possible. And the second one is now we are participating to this new revolution of artificial intelligence. So we are combining our high throughput screening facility, which is still unique in the world, with our artificial intelligence specialist. And we are developing now, it is not finished, it's just ongoing, prediction for making catalyst with robots. And we will design an expert system, which is able to design a catalyst from scratch with the computer, AI, artificial intelligence, and our robots, which can make the experiments. What is very challenging, it's when you get a job, the president of university tells you that you will have to spend 1/3 of your time teaching, 1/3 of your time making research, and 1/3 of your time making administration. But then you realize that you also need 1/3 of your time to looking for funding, 1/3 of your time for reporting, 1/3 of your time for management, and then 1/3 more of your time for human relationships and for conflicts between people. So in fact, what is challenging is to handle all of these aspects at the same time. And then the last but not the least, when you're in a very competitive system, when you are in the academia, also in the industry, and believe me, the people you are working with are also very, very good scientists. So many people are really excellent. If you want to be the best, you need to capitalize on soft skills, on cooperation, because the point is everybody is very good to make science. And then if you develop soft skills, you are able to talk with people, able to make cooperations, able to make people joining your research. You will get a lot of results, and it's much better than working isolated as one single person. That was the main point I wanted to stress out. Thank you very much.
Oh, thanks, Frank, and big congratulations to you on the new university.
Thank you. That's the secret at the moment. In 2 weeks,
I'm gonna have to get started on my own new university just to feel like I'm keeping up. Any questions for Frank?
Hi, Frank. This is Helen. I have a question. So you're a professor in this French university. How is that academic-wise different from the US?
Well, this is a difficult question because I'm not so aware about what is ongoing in the US, but I have some points I can tell you. So I have an academic position in France, and the main difference I feel is that I am paid during 1 year. I think in the US you are paid 10 months, and then you have to get your salary from your project, right? Is something I understood? I'm correct? So here I have a fixed salary. Of course, I can have also other incomes. And then another difference, I thought about something, but sorry, I just lost the point when while speaking. Yes, we don't have at the moment tenure tracks. So this is I think it's a very good point of the US system, these tenure tracks. And now from this year, the French government is trying to make a copy of this very nice feature of the tenure tracks. And I think we will be able to start some tenure tracks in 6 months, which is a revolution for France we like revolutions, you know, which is a revolution because usually French people think that when you are hired in the public service, you are hired for life, and this is a duty that the government has toward you. And making tenure tracks, now it's a change, a game changer, and I think we will make it, and we will be able to recruit some, more and more talented people. That was the two main differences I felt between US and Europe, as far as I understand the US system.
Great, thank you. That's, yeah, I did not know that about the tenure track too. Thank you.
We've got a question in the chat box from Ronald Marquez. Congratulations, your group is a big group. Veronique Rataj and Robert, is that Wojciak?
Wojciak, yeah.
Wojciak groups are great. So the question is it feasible for the Europe industry to move totally to green and bio-based?
I like this question because I have many angles I can dig into to answer. First, what Europe is not good at is this. We are making a lot of patents, believe me. But as a matter of fact, Europe seems to be unable to implement the patents innovation within Europe. So we are, the beneficiaries are US, Asia, and so on, which is good for you, but maybe not for Europe. There are many reasons I could speak 2 hours about this. Then we have something very new in Europe since 10 days ago is the war with, I'm sorry to talk about this, with Russia against Ukraine, and we realized, we knew that, but now with the war, it's something which is becoming very important, that a lot of our energy is coming from Russia, in fact. Gas and so on. And now this question is a very good question, because can we get some independency for energy, but not only for energy, for bio-based? The answer at the moment is not. We have the biomass. I think it's not the problem of biomass, but the first problem I just mentioned is that we are not very good to translate patents into innovation on our territory, but outside Europe, we're very good to do that. That's a point. And then we don't have the subsidies to make it, because as you know, the carbon issued from biomass is a bit expensive compared to petrocarbon. And in Europe, we have subsidies if you are making biofuels, but not subsidies if you are making chemicals and materials. So that's a very bad point. But maybe this conflict on the east of Europe might be a game changer, because the governments are talking about becoming independent. So maybe they will put the money. The main break is the money in that case, in my opinion, at least.
That's also a very hard and nuanced question to answer in a short period of time, isn't it? I think
Zoran speaking here. I have a remark. I don't understand what independence for energy or whatever. This doesn't exist. If you don't get from Russia, you will get from someone else. So you will be dependent from someone else. Now, if you want to depend independent of everyone, you will have to produce everything in
yes,
and
sure.
that's possible. So the best way really that we avoid situation as it is now, rather than have wars about oils and whatever.
Yeah, but my comment was to tell that if you want to for the energy, if you want to change the deal in the energy, it takes a long time. It is not straightforward. If you want to have a new supplier, you know that you have to negotiate, and it takes a long time. If we could to a certain extent, be able to produce more energy from biomass in Europe, we would have a kind of possibility to be more resilient when something changes from the outside. I'm not a nationalist, that's not the point, if it's a point you wanted to raise, but we realize that we are too dependent on some streams and it is too concentrated in that case from the east of Europe. That's just the point I wanted to raise.
Yeah, but it's only not energy, but also materials.
Yeah, yes, sure. It's not only
yeah.
for sure. Yeah, sure. I totally agree.
All right. Well, thank you, Frank, and great discussion. I think we need to keep moving on. So our next speaker is the first of two speakers representing careers in government science labs. So our first of those is Bob Rowe. He was born and raised in Massachusetts and received his BA in biology from Boston University, and also got a Bachelor of Science in Chemistry from Francis Marion College, and got his PhD in plant biochemistry from the University of South Carolina. After a 2-year postdoc at UC Davis, he was hired as a research chemist at the Eastern Regional Research Center of the Agricultural Research Service, which of course is a part of the USDA, in Winmore, Pennsylvania. He's enjoyed conducting research there for 38 years and recently retired in 2019. During his career, his research topics have included plant lipid enzymology, analytical method development, biofuels, and development of processes to produce biofuels co-products from things such as corn fiber oil, phytosterols, and also waxes. So with that, Bob, the floor is yours.
Fine. Can you hear me?
Yes.
Good. Well, welcome everyone. I did list some of my career highlights, and I'm happy to spend a couple minutes with you today. Eric did mention that my PhD was from the University of South Carolina, and I was fortunate to have an assistant professor who was very interested in training graduate students and getting tenure. And it was a good combination. He spent a lot of time beside us and was an excellent mentor. I then moved on to UC Davis. In a different atmosphere, Paul Stumpf was a member of the National Academy of Science. And at that time, there were 6 other postdocs in the laboratory. It was a very congenial and intense research environment. 2 years later, I was hired as a research chemist at ERRC, as Eric mentioned. Along the way, I was invited to be an associate editor for lipids, and I guess I might mention the importance of this. What happened, Howard Knapp was the associate editor at that time, and he had asked me to review a couple papers. And about a year later, he called me up and said, Bob, you write pretty good reviews. Would you like to be an associate editor? So I said yes, and that was a good experience. I guess the next stepping stone that I have on the highlights here, in 2003, Howard Knapp was on the governing board of AOCS and to become one of the presidents. And he called me up and said, Bob, you're pretty good as an associate editor. Would you like to be chairman of the publications committee and a member of the governing board? So I said, yes, that sounds like it's interesting. And one of the things that happened a year or two after that was that AOCS had the opportunity to partner with Springer for our journals. And I was involved in those negotiations, and there were negotiations with other publishers, but I think that was a very good thing for AOCS. So serving on the governing board was also a great opportunity for networking and developing collaborations in my research. The next thing I listed on my highlights is appointed as a delegate to Codex Alimentarius. Codex Alimentarius is an international group that develops trade standards. And there are different commodity committees. I was on CCFO, which is the Codex Committee for Fats and Oils. So this committee meets in Malaysia. Malaysia is the host country. And it's fairly at an expense to them, but an expense that allows them to promote their palm oil. So I was able to travel to Malaysia 5 times during my career to negotiate updates in the trade standards for all of the major commodity oils. And that was a very interesting opportunity to represent the United States with this international group. Usually there were delegates from about 50 countries that produce and trade edible and industrial oils, and 50 countries, and there were 2 or 3 delegates from each country. Later on in my career, I entered a program called the Executive Potential Program in the government, received some valuable leadership training, and part of this training involved working in Washington, D.C. in the headquarters of the U.S. Department of Agriculture in the Undersecretary of Agriculture office, and learning how the wheels of research for government work was very valuable. I guess the last 5 years of my career, I did serve as research leader, led a group of 10 PhDs in Winmore. 3 of them that are on the call right now, at least 3 are part of that group that remains in Winmore. So just a couple comments. I might mention one of the things that I liked about ARS was the fact that ARS provides base funding for your research. ARS scientists are assigned to 5-year research projects, and every 5 years we write proposals for what we think is valuable to do for the next 5 years. And then those proposals are peer reviewed, and if they're approved, your project is approved for 5 years. And unless there's a crisis, you're assured that you're not redirected and are working on that same progress. You are encouraged to write research grants, and in my career, I was fortunate to receive 4 major grants that allowed me to hire postdocs, and that was a nice way to supplement the base funding. Eric asked me a couple questions that I'll try to answer quickly. One was, what is the key to getting started in your field? And I would say that in government research, publishing, it is like academia, publish or perish. As I mentioned, getting grants isn't it isn't a requirement. It does help you to be able to do more research. Networking is important, and I mentioned my affiliation with AOCS and how that helped with networking. Developing good collaborators is also important. What are some of the most rewarding moments? I mentioned the opportunity to serve as a U.S. delegate to Codex. That was very, very rewarding. When I was a postdoc, my PhD advisor in 1979 was one of the first US scientists to visit mainland China, was invited to come in and do a lecture tour. And after that tour, he came back to the laboratory, and not long after that, the scientist who served as his translator came and spent a year working in the laboratory. That scientist had been part of the Cultural Revolution and had been away from research for many years. So it was a reacquainting him to research. And when I was a postdoc, I always thought that would be a fun thing to do, to go to China, to give a series of lectures, and then to come back. And in 2011, lo and behold, I was invited to go to China to speak in 2 different research institutions. And when I came back, the man that served as my translator asked if he could come and work with me for a year in my laboratory. So it was just kind of rewarding to have that wish early in my career and then have it fulfilled. Another thing that was kind of fun, in 2012, I was asked to serve in a PhD advisory committee in Sweden. And during my career, I probably served in 15 PhD advisory committees. most in the US, some in Europe. This one in Sweden was kind of fun because in Sweden and the other Scandinavian countries, they have part of the PhD defense. One of the people on the team is called the opponent. And the opponent is the one whose job is to grill the PhD student. And it was a challenging and interesting opportunity, and very, very different than our PhD program here. So how am I doing with time?
I think if we could wrap things up leave a little bit of time for questions, that would be good. But I don't want to cut you off prematurely though.
Okay, I think I have covered just about everything. You asked what are the most challenging things in the field. I would say that one of the most challenging things is leading and managing researchers, something that for all of us in research is both rewarding and challenging, as leading and managing. So I think I will wrap it up there. Any questions?
Yeah, well, thanks a lot, Bob, and also congratulations again on the A.R. Baldwin Award for service to the AOCS. That's very much appreciated. Any questions for Bob?
So one question, this is BK. For the young professionals who are interested in joining federal labs or the newcomers, tell us, how did you navigate your career in the federal lab?
Could you repeat that?
How you navigated your career in the federal lab?
How I navigated my career?
Mm-hmm.
I guess, as you know, we are evaluated every 3 to 5 years with the RPES system, which is a research peer evaluation system, somewhat similar to tenure, but I think it's a little bit more objective, and our research is evaluated for numbers of publications, but also the impact of publications. So impact can be things like impact factor for publications, but also did the research lead to commercialization? How valuable was that to other people? So I guess in contrast to the people in academia that have 1/3 of their time for various things, one of the nice things about being in the government laboratory is that we can focus a major percentage of our time on doing research.
Okay, thank you, Bob.
You're welcome.
We have one question in the chat box from Ronald Marquez. Congratulations, great career and service. Do you recommend publishing in AOCS journals based on your experience at the governing board? Which are the benefits of publishing with AOCS?
What are the benefits of publishing with AOCS?
Yes.
Well, in the earlier days, there were publishers had charges for publishing papers, and you don't need to, pay page charges for AOCS. I think having the exposure to other people in AOCS and the respectable impact factors.
Great, well, thanks much again, Bob. And I think, now we'll move on to our second government scientist speaker, Bob Dunn. So Bob Dunn received his PhD in chemical engineering in 1987 from the University of Oklahoma, and went on to do a postdoctoral fellow at the US DOE at the Morgantown Energy Technology Center, working on surfactant flooding systems for enhanced oil recovery And beginning in 1998 or 1988, he has been a senior research scientist with the Bio-Oils Research Unit at the USDA ARS in Peoria, Illinois. Dr. Dunn has contributed to the research and development of various alternative diesel fuels made from vegetable oils and animal fats. His initial research was on the topic of microemulsion fuels, composed of blends of soybean oil, methanol, and surface active agents, also known as surfactants, including medium chain alcohols and fatty alcohols. His current research is in the areas of identifying and developing low-cost, non-food feedstocks, modifying the fuel properties, and improving the performance of biodiesel.
All right, thank you, Eric. I guess I'll start by repeating some of my past history. I did serve 1 year with the DOE lab in West Virginia. And I suppose many of you are wondering, why would somebody be interested in enhanced oil recovery in what is major coal country? And the basic answer is there is a former Phillips 66 research scientist who had set up a small group in Morgantown that was looking at surfactant flooding. And all surfactant flooding is just injecting, I guess, mixtures into the ground in an attempt to lower the interfacial tension between the oil and the water or CO2 that might subsequently be pumped in the ground to force the oil out. Not many people realize that when oil is discovered, I guess, underground, the initial output from the wells is a very small percentage of the total amount of oil that's generally located underground like that. This technology was considered on the state of the art at that time, and has been used by many petroleum companies ever since in their attempts to literally squeeze more and more oil out of the ground. Subsequent to that, I took a job, just a full-time job right away with the Department of Agriculture here in Peoria. And I initially worked on what were then termed as microemulsion fuels, and the object of which was to mix methanol and soybean oil or other vegetable oils together in a unique blend that would lower the viscosity of the soybean oil. Typically, a diesel engine is very sensitive to the viscosity or resistance of flow of the fuel. So soybean oil tended to have about a viscosity about 10 times higher than what was desired for efficiently operating the engine. So if enough methanol could be mixed with the soybean oil, then that viscosity could be lowered in the overall mixture. The problem with that approach was methanol is very polar and soybean oil is not, at least relative to methanol, and they don't want to mix together easily, hence the need to mix in a third agent, which were medium chain, just simple alcohols such as propanol, butanol, and so forth, or fatty alcohols, which used to be made from fatty acids, I think, of vegetable oils obtained through refining and so forth. That research was very productive, and I was primarily involved in that in the first 5 or 6 years of my career with ARS. Then one day, my research lead at the time, Marvin Bagby, brought me a pint of a 4-point depressant that was called Paramins. I believe it was an Exxon product, or at least an experimental product at that time. And he said, I need you to mix this with some biodiesel or fatty acid methyl esters of soybean oil and see what happens to the 4-point and the other cold flow properties. At that point, I knew very little about biodiesel or its cold flow properties. So I took about to doing the proper literature research. I learned all I could about not only diesel fuel and its cold flow properties, but how they were treated. And the most efficient way was to treat them with additives. So I developed I guess at the time I called it a testing protocol for cold flow properties in the lab in Peoria, and produced a couple of papers that was viewed by the National Biodiesel Board, as it was called at the time, as very central to their efforts to try to establish a fuel standard for biodiesel, which basically appeared sometime around the late 1990s. So one of my more rewarding experiences as a research scientist with ARS has been my involvement in not only in doing the research and providing the data, but into some of the conferences and meetings that I attended in efforts to establish fuel standards, not only for ASTM, but at the time, I think what we now call the American Society of Agricultural and Biological Engineers was also looking into a standard of its own. I think they ended up finally agreeing mostly with the ASTM standard, but these were very rewarding times for me. Now, early on in my career, I was given some advice on what to do about publishing my research. And this is something that Bob Moreau touched on in his short presentation. He's right. ARS is very much like academia. It's publish or perish. Research scientists are required to have a certain number of publications in output every year. It's always best to have more than that minimum number, but they are required to do that. And a former, I think, associate area director gave me some advice when he said, when you're publishing your research, publish in journals and other media that are designed to get the message you want to get to the people you need to have hear it. And that would be my stakeholders. Impact factor is important, but at the end of the day, it's just a statistic. If you have a number of people reading, for example, a journal of the American Oil Chemists Society that are interested in your research, then that is a natural place to publish your research. And so I have had many publications through the years published in the JAOCS. In my, I guess in my later career, I've essentially continued to work on biodiesel. There was a brief hiatus between about 2012 and 2017 where I continue working on fatty acid methyl esters, but in a different capacity. But now we're back into it. And as I said, there's a recognition that we need to develop more sources for feedstocks for not only biodiesel, but bio-based products in general. There is increased demand for higher, I guess, blend ratios of biodiesel in transportation fuel. At the moment, I believe B20 is very popular in many states and many local areas. But there's a desire to increase that blending ratio up to maybe 50%. And there's some places and markets and sectors that might require even a higher blend ratio, such as in marine type fuels. So there's a need to develop these feedstocks, and our project is currently looking at what I call low-cost non-food type sources. One of which was actually the gene-modified pennycress that Tim Umasaw was briefly touching on in his presentation, converting that into biodiesel and testing its properties. Also looking at other sources. Some of these fatty acid compositions need to be modified to, as I said earlier, to improve their cold flow properties, but also improve their relative stability during storage. And I'm sensing that I'm getting close to the end of my my time slot here, so I'll just say that it's been a rewarding career. I've been working for ARS now for more than 30 years. In a couple of years, I'll be joining Bob Moreau into the ranks of the retired and former government employees. It's very unusual, I think, for nowadays for people to work at the same position, especially in research, for such a long period of time. And I have to admit, when I first arrived in Peoria in 1988, having grown up in Oklahoma, it was a bit of a culture shock for me. So I ended up telling myself, maybe I'll give this 5 years and see how it's going. Well, I suppose I'm still trying to decide how it's going. So on that note, I thank you for your attention. I'll be happy to answer any questions that you may have. Thanks again. Are we still online?
Yeah.
Yep.
Yeah, thanks a lot, Bob. I have to depart actually for another meeting, so I'm going to turn over the emceeing of the final few minutes to BK to handle questions and also introducing our final speaker. So thank again, everybody, for attending, and I hope to see you all at the meeting.
All right, thanks, Eric.
Thanks, Eric.
Thanks, Eric.
Bye-bye.
We did have one question come in through the chat, Dr. Dunn, and it was Ronald Marquez thanking you. And he said, do you see a future in using wood pyrolysis oils as a fuel, which would be the direction for bio-based fuels, vegetable oil or wood-derived fuels?
There's a lot of concern nowadays in using vegetable oils as a feedstock for any type of fuel, especially now with all the, I guess, uncertainty in the food and some of the food commodity markets. So my advice would be to maybe look towards what I would call residues or biomass, and certainly wood pyrolysis would qualify under that. Pyrolysis oils, from what I understand, are just only some of the products that can be obtained from that process. There's also biogas, and of course there's a solid fuel that can be obtained from that as well. So as far as oils that I'm interested in looking at, I'm looking at things like messy, dirty, disgustingly awful used cooking oils, things like that nobody really wants to use as a food in a food processing environment, at least not any longer. Trap greases are in there. Many of these things have already been tried and researched, so I'm actually trying to develop a little more creative approaches to that as well, looking at oil residues from corn and sorghum fermentation and so forth. I understand that's probably a little more generalized answer than you may have been looking for, but that's kind of my outlook on that.
Yeah, and then Tim had his hand raised. So Tim, if you want to unmute yourself, you can ask your question.
Yes, thank you, Bill. I have a question and a comment. Let me start with a comment. Just thanking Bob, because really without your work, Bob, and the work of people like Terry Isbell, Roque Evangelista, Emil Evangelista, I think CAVACRES would not be here, would not be in existence. So the early work that you've done at that Peoria, Illinois site was really foundational. So thank you very much for that. With regard to kind of the future of biofuels, my question is, most of your work you've done on the biodiesel, but from what we are learning here is that the current capacity for future biofuel production from vegetable oils is mostly focused on renewable diesel, which is a different process, right? Without kind of esterification. And what can you say with regard to the future of regular biodiesel, or the properties of the oils that need to be developed for renewable diesel?
Well, first of all, some people have predicted that biodiesel is going to become less emphasized in the market in favor of renewable diesel. From a technical standpoint, renewable diesel is just, it's similar, it has a similar feedstock to biodiesel, but the product has been stripped of its heteroatoms, and mainly oxygen. It's considered, I guess, a cleaner fuel than than distillate, or what I call distillate, but really conventional diesel fuel, because it doesn't have some of the other nasty items in it. One thing that biodiesel does provide, I don't think that renewable diesel does, is better lubricity in blends, but you only need to have about 2 or 3% of biodiesel in there to take advantage of that. I would say that at this point, I mean, the National Biodiesel Board has recently undergone a change in its name because it's starting to accept more and more the likelihood that renewable diesel is going to continue to increase in terms of not only capacity, but also its use in the marketplace.
Thank you, Bob.
That's about as neutral an answer as I can give on that.
That's a great answer. Thank you.
Thank you, Tim. That's a good question.
Thank you, Bob. Thank you so much for your insight on your career. And we'll move to the next speaker. Our next speaker is Dr. Naku Hernandez. He got his PhD from Iowa State in 2012, working on the research and development of bio-based materials from sustainable and renewable resources. He's a co-inventor of more than 20 granted US patents and author of numerous research papers in bio-advantaged materials. In 2020, he joined Soile Innovations team, and in 2021, he was named CEO. His areas of interest are in the research, development, and commercialization of biomaterials, mainly thermoplastic, elastomers, and novel bio-advantaged monomers from renewable resources, such as vegetable oils. He has led several research initiatives, including the use of bio-based polymers in the modification of asphalt pavements. In 2019, he was the winner of National Corn Growers Association Consider Corn Challenge 2, and that recognizes technologies that expand the use of corn. So let's hear it from Naku.
Thank you, BK, for the introduction. Good afternoon, everybody. Pleasure to be here. Thanks, AOC, for the invitation to come here, something to share my short experience on starting a new business. As BK mentioned, I did my graduate school at Iowa State. Actually, Eric was my mentor. I work in the research and development of bio-based material, more specifically, develop a line of thermoplastic elastomers out of soybean oil. And as you know, we heard this first application was in using asphalt pavements, the modification of asphalt pavements. And I was lucky enough that early on, this idea got some traction from private industry that wanted to explore the possibility of producing these materials in larger quantities. So wanted from transferring from just creating few grams at a time to mass producing, and then subsequently the commercialization of these materials. Now these materials have evolved into a platform of oil-based products that can be used in a different applications in a wide variety of markets. However, I believe that somewhere in this process, I realized that I really wanted to do this full time. I had really enjoyed the interaction that I had with industry. I enjoyed the possibility of developing a product that not only could be used by consumers in short term, but also that these products could have a positive impact in the world that we live in. And with this in mind and a group of people, we started Soile Innovations, a startup which goal is to develop and commercialize soybean oil-based materials to use in a wide variety of applications. And as I mentioned, starting with the use in asphalt modification as our main product right now. And with this help the farmers by getting more value out of their crops. However, this business has not been an easy endeavor for us. As we heard from Tim, you have to be able to wear multiple hats all the time, and especially when you at the beginning where you don't have money, you have to wear all the hats and at one time. And in our case, we also started a company before all the COVID halted most operations around the country, causing a lot of supply and logistic issues. In our case, most importantly, vegetable oil prices has skyrocketed in the last few months, as you know, and this has increased our raw materials for more than half. So just dealing with that, and that has been kind of a challenge. However, if just mentioning what has been our most challenging aspect of our creation of the company is dealing with the human relations, the management of people. So I guess what we have learned, selecting the right team, the right team of people that you want on your side to fight the battles on the early start, it is of utmost importance. However, through this, also these relations I have met incredible people that are always willing to help and really teach the new generations of these, startups, and helping us grow the company that I have been lucky to lead so far. And on the other hand, one of the most rewarding moments in my professional career is when we had our first sale, knowing that someone has trust our team enough to spend their hard-earned money to buy our products. I think that is extremely humbling and exciting at the same time, and giving more reasons to continue in this endeavor. With that, I think I'll be happy to answer any questions.
Any questions from Naku?
Naku, I had one. What would you say would be what made you decide to go out, and start your own business? What was there something specific that sort of prompted that?
Yeah, we had several people interested, private industries working on this. And sadly, most of these interactions with big industry always delayed our progress and our hopes to really see these commercial products, in the short time frame. Most of those relations, didn't take anywhere. So we wanted to basically take this research in our own hands and really, if we really wanted to succeed and really wanted to see these products out there, we realized that it had to be done by us and not relying on other people to really carry the baton to the last stage. So that was basically what, we saw that there was the delay of going into, big corporations. We rather decided to do it by our own.
I have a quick question for you. What message do you have for the professionals who would like to go in the startup companies or start a new company?
I guess if you truly believe in your technology, and in my case, it was my PhD thesis. If you truly believe in what you are researching, I think it is always worth your time on doing this, because even though you can, at the end, you may not succeed, but the learning that you get through this process has been really life-changing for me. So yes, it is not always the reward is money. It's also the connections you get, the friendships you make, that is really has been worth it for me.
Okay. Thank you so much, Naku, for all the information. And I would like to thank all the speakers for your time and sharing your career stories. I'm sure the younger generation, they will benefit from the insight you have provided and help them select the right career path. Thank you. Thank you so much.
Yeah, thank you guys. And BK and Helen, I think we have to wrap it up just because we are a little bit past time, to say
Sure.
the least.
Yeah.
So
Yes.
again, to echo what BK was saying, thank you all so much for sharing your stories. It's amazing, and I think it gives a lot of value to some of our younger members that are trying to figure out how to sort of navigate what this whole thing is in the industry, and it gives them multiple different viewpoints of different directions they can go, because you all have had extremely interesting and different experiences going through this and how you got to where you are. So again, I really appreciate it. BK, I'll leave it up to you to close out.
Yeah, I think we have a great sessions lined up for you in the AOCS annual meeting this year. So I hope a lot of you can join in person or virtually, and we'll see a lot of you in person or in the Atlanta for the meeting. And there are a lot of opportunities for young professionals to join the IOP division, and then also they can participate in different positions, and there are chair positions, there are other positions that are available in the division. So with that, I think once again, I would like to thank all the speakers and thank you all for such a great session.
Thank you, everyone.
Thanks, everyone.
Thank you, everyone.
Thanks, everybody.
Thank you.